Hello, good day, viewers. In our previous lesson, we have seen the introduction to the Riemann sum. And here is our first problem. The question reads, use the figures below. You can see them here. We have two figures to calculate the left and the right Riemann sums for the function on the given interval and the given value of n. Remember, I told you n is nothing but the number of rectangles given. So in this case, you can see 1, 2, 3, 4, 5. We have 5 rectangles. And the function is x plus 1. The interval is 0 to 5 inclusive, n equal to 5. So before we start, I would like to show you the difference between the left and the right Riemann. When we're talking about left Riemann, after you have inscribed the rectangles, every single rectangle must have equal base. So from here to here must be the same distance from here to here, the same base, but the height depends on the value of x. So when you're talking about left Riemann, the height of every single rectangle is determined by its left leg. So let's use this first rectangle here. You can see it has two legs, but its height is determined by the left leg. This is why it is called the left Riemann. But if you come to this one, you can see that it has two legs, but its height is determined by the right leg, not this one anymore. You have to consider the second leg. That is the right Riemann. And another difference between them, talking about this particular function x plus 1, the area here is underestimated. Why? Because we have some left portion that are left uncovered. You can see them? Because the actual area must cover every portion under the function to the x-axis, under the curve to the x-axis. But this one is overestimated because we have some extension outside the main area. So in order to find out whether this is actually underestimated or overestimated, let us compute for the actual area by taking the definite integral. So to find the actual area, you have to integrate this function on that given interval 0 to 5. So 0 to 5 of the function which is x plus 1 with respect to x. So this is equal to the integral of x will give us x squared divided by 2. The integral of 1 with respect to x will just be x. And the limit is from 0 down to 5. We are only going to substitute the upper limit because the lower limit is 0. Substituting 0 here will make everything 0. So this is equal to, wherever we have x, we replace it with 5. This will be 5 squared divided by 2. Then plus another x, which is 5. This is equal to, this is 25, right? Divide by 2 plus 5. 2 times 5 is 10, and 10 plus 25 is 35. So this is 35 divided by 2. And you can also write it in decimal as 17.5. So 17.5 is the actual area. I think let me write it down here. So area is equal to 17.5. This is the actual area, because Riemann sum is nothing but approximation of the actual area. It could be overestimated or underestimated. All right, let's start with the left Riemann sum. Remember the formula, area is equal to dx multiplied by f of x1 plus f of x2 plus, you keep on adding them up to f of xn. That is the last one. So what is dx? Dx is nothing but the base of every single rectangle here. So what is the distance here? From 0 to 1, you can see this is just 1 unit, and from 1 to 2 is another 1 unit. So the dx is 1. But suppose the diagram is not given to you, you can always use this formula. Dx is equal to b minus a divided by n. B here is the upper limit, this is lower limit, n is the number of rectangles. All right. So we have seen that dx is 1. So a is equal to 1 multiplied by f of x1 is what? That is the height of the first rectangle. So this is the height of the first rectangle. You can either take 0, plug it into that function, which is x plus 1, or you can simply take it from here because you can clearly see it. It is 1. The height of this rectangle is 1. And even if you substitute 0 here, you have 0 plus 1, which is still 1. So you replace this with f of x1 is 1 plus f of x2, that is the second rectangle. This is that. This is its height. You can see it is 2. This is 2 plus the third rectangle is this. Its height is 3. You can see that right here. So we have 3. Then the fourth one, you can see it is 4. And even the last one, you can see it is 5. So we have 4 plus 5 plus 4 plus 5. So once you compute this, it will give us the approximated area. So let's compute. This plus this is 3. 3 plus 3 is 6. 6 plus 4 is 10. And 10 plus 5 is 15. Then multiplied by 1 outside. 15 times 1 is still 15. So A is equal to 15. So this particular area is 15 units squared, but the actual area is 17, which means that the area is underestimated. But remember, I told you, the more the number of rectangles are inscribed, the more you get closer and closer to the actual area. Remember that. So now this is the left Riemann. I think let me name it as left Riemann. This is the left Riemann. So let's compute for the right Riemann. The same formula. We have A to be equal to dx remain 1. So what is going to be the height of the first rectangle? You can see this is the first rectangle, and you have to consider the right leg, and its height is 2. Let me take them once at a time. The second one is 3. That is 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. So we have 2, 3, 4, 5, 6. So now let us add all of them together. 2 plus 3 is 5, plus this is 9. This is 14. Then this is 20. 20 times 1 is still 20. So you can see that the right Riemann sum is equal to 20 unit, which is overestimated because it is greater than the actual area. And another thing you should note about this Riemann sum, if you add the left and the right Riemann sum, divide by 2, it will give you an area which is closer to the actual area. Let's do that. Let's take the average. Left plus right divide by 2. This is 15 plus 20 divide by 2, because you can remember the left Riemann is 15 and the right Riemann is 20. If you add these two together, you have what? 35. So this is 35 divided by 2, which is exactly 17.5. You see, by taking the average, we're able to obtain exactly the same area. But it's not always true. But the moment you take the average between the left and the right Riemann, it will give you that area close to the actual area. So this is our first example. Subsequently, we're going to solve as many as possible. Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.